Welcome back. In this tutorial, we will learn about column chart. A column chart is a graph that shows vertical bars with the axis values for the bars displayed on the left side of the graph. It is a graphical object used to represent the data in your Excel spreadsheet. You can use a column chart when you want to compare values across categories. Benefits of using a column chart are they are simple and easy to understand, versatile. You can add data labels at the end of the bar easily. Under column chart, we have clustered column chart, stacked column chart, 100% stacked column chart. You can also have the 3D version of this chart. Clustered column chart. When you want to compare values across a few categories, you need to use a clustered column chart. A clustered column chart displays more than one data series in a clustered vertical column. Each data series shares the same axis label, so vertical bars are grouped by category. Clustered columns allow the direct comparison of multiple series, but they may become visually complex with large data. They work best in situations where data series are limited. Stacked column chart. A stacked column chart is a basic Excel chart which allows part-to-wall comparison across categories for over a time frame. In a stacked column chart, data series are stacked one on top of the other in vertical columns. Stacked column chart can show changes over time as it's easy to compare total column length. Benefits of using stacked column chart are in a compact space, multiple series of data are represented and you can highlight trends and changes over time. 100% stacked column chart. This shows the relative percentage of multiple data series in a stacked column, where the total of stacked column always equals 100%. The 100% stacked column chart can show the part-to-wall comparison over time. For example, the proportion of quarterly revenue per region, or the proportion of monthly commission payment that goes towards vendors or agents, etc. In a stacked column chart, it's difficult to compare the relative size of the components that make up each column. Now, let's see how it's done. In this example, we have headers like products and years. Products include apple, mango, pineapple, etc. And years include 2007 to 2017. Let's create a chart. Select the data. Click on Insert tab. Under All Charts, click on Column Chart and then select Clustered Column Chart. To change the data, click on the chart, right-click, click on Select Data and then drag and drop the data you prefer for this chart and press OK. Resize the chart. Now, to make a stacked column chart, just copy-paste the existing chart. Right-click, change chart type and under column chart, select Stack Column Chart. Now, to make a 100% stacked column chart, follow the exact same step. Just copy-paste the existing chart. Right-click, change chart type and under column chart, select 100% stacked column chart. Now, we have 3 column chart and you can find how the data is displayed differently in all 3 charts. Simple as that. Welcome back. In this tutorial, let's learn more about the bar chart. A bar chart is a graphical chart that shows horizontal bars with the axis values for the bars displayed on the bottom of the graph. It is a graphical object used to represent the data in your Excel spreadsheet. You can use a bar chart when to compare values across categories between different duration and when category text is long and difficult to display in a column chart. Benefits of using bar chart are simple to understand, easy to read, versatile, room for longer text labels and easy to add labels at the end of the bar. Under bar chart we have clustered bar chart, stacked bar chart, 100% stacked bar chart. You can also have the 3D version of this chart. Clustered bar chart. When we want to compare values across a few categories, you need to use a clustered bar chart. A clustered bar chart displays more than one data series in a clustered horizontal bars. Each data series shares the same axis label. So, horizontal bars are grouped by category. Clustered bars allow the direct comparison of multiple series in a given category. Like the clustered column chart, clustered bar chart become visually complex as the number of categories or data series increase. They work best in situations where data points are limited. Stacked bar chart. A stacked bar chart is a basic Excel chart type meant to allow comparison of components across categories. Data is plotted using horizontal bars stacked from left to right. Stacked bar make it easy to compare total bar length. However, except for the first series of data, it's more difficult to compare the relative size of the components that make up each bar. Also, as categories or data series are added, stacked bar chart quickly become visually complex. Benefits of using a stacked bar chart are: in a compact space, multiple categories and data series can be displayed, able to show change and trend over time of category and subcomponents. 100% stacked bar chart show the relative percentage of multiple data series in a stacked bars, where the total of each stacked bars always equals 100%. A 100% stacked bar chart shows a par-to-wall relationship. A 100% stacked bar chart can show how proportion changes over time. Now, let's learn how it's done. In this example, we have headers like products and years. Products include apple, mango, pineapple, etc. and years include 2007 to 2017. Let's create a chart. Select the data. Click on Insert tab. Under All Charts, click on Bar Chart and then select Clustered Bar Chart. To change the data, click on the chart. Right-click, click on Select Data and then drag and drop the data you prefer for this chart and press OK. Resize the chart. Now, to make a stacked bar chart, just copy-paste the existing chart. Right-click, change chart type and under bar chart, select Stacked Bar Chart. Now, to make a 100% stacked bar chart, follow the exact same steps. Just copy-paste the existing chart. Right-click, change chart type and under bar chart, select 100% stacked bar chart. Now, we have 3 bar chart and you can find how the data is displayed differently in all 3 charts. Simple as that. Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about histogram and Pareto chart. Histogram. A histogram is a column chart that shows frequency data. Though column charts and histogram looks familiar, column charts are designed to show volumes and histograms are designed to show frequencies. In x-axis of histogram, instead of category labels, we have bins, ranges and values, where height of the rectangle associated with the bins indicate the number of observations that falls within those ranges. To create a histogram, you must organize the data in 2 columns on the worksheet. These columns must contain input data and bin number. Input data is the data that you want to analyze by using the histogram tool. Bin numbers are the numbers that represent the intervals that you want the histogram tool to use for measuring the input data in a data analysis. When you use histogram tool, Excel counts the number of data points in each data bin. A data point is included in a particular data bin if the number is greater than the lowest bound and equal to or less than the largest bound for the data bin. If you omit the bin range, Excel creates a set of evenly distributed bins between the minimum and maximum values of the input data. In this example, we have headers like income, expense, and age group. Histogram work best when you have large data set containing continuous variable. These charts are commonly used to show the distribution of continuous data set. In this example, we will learn how height, weight, and age is distributed among the sample population. So let's get started. Select the data, in this case, column with header height in inches. Click on Insert tab. Click on All Chart. Under All Chart, select Histogram and press OK. In this case, Excel automatically selected the bin sizes. We can also adjust the bin size based on our preference. Let's add data labels and change the title as Heights in Inches. These bins represent ranges of height in inches and number of observations that fall within that ranges. In this case, it states that there are 39 people that falls between the range of 68 and 75 inches and 10 people that falls between the range 48 and 55. There is a bin size of 7 and bin width of 6.8. To customize the bin size, click on the bin, right-click, click on Format Axis. In this case, Excel has selected the automatic bin option. Let's change the bin width as 10 and number of bin as 5 to make it more readable and simple. Right-click and add data labels. Now, you can see a normal distribution with a classical bell curve where majority of observations fall within relative narrow range of height, and you got some outliers on either end of the tail. Now, let's give a gap width between bins. Right-click on the chart, select Format Data Series. Select the gap width as 10%. Now, we have a histogram which shows height variation in a sample population and number of people that fall between 48 inches to 98 inches in 5 different bins. Simple, isn't it? Now, let's create a histogram for weight. You don't need to again create a new chart. Just copy-paste the existing chart. Click on the chart, right-click, select Data Series. Under Legend Entries, delete the current data series. Then, click on Add. Enter the series name as weight in pounds and series value as C20 to C120 and press OK. Add data labels. Let's change the title as weight in pounds. Let's customize the bin size to make it more simple and easy to understand. Click on horizontal axis. Right-click, Format Axis. Currently, Excel has selected 8 as the bin size. Let's change it to 7 bins and bin width as 15. Let's give a gap width of 10% by right-clicking on the histogram chart. Format Data Series. Select the gap width as 10%. Now we have a histogram which shows weight variation in a sample population and number of people that falls between 125 pounds to 250 pounds in 7 different bins. Simple, isn't it? Now, let's create a histogram for age group. You don't need to again create a new chart. Just copy-paste the existing chart. Click on the chart, right-click, select Data Series. Under Legend Entries, delete the current data series. Then, click on Add. Enter the series name as Age Group and select value as D2 to D120 and press OK. Add data labels. Let's change the title as Age Group. Let's customize the bin size to make it more simple and easy to understand. Click on horizontal axis. Right-click, Format Axis. Currently, Excel has selected 13 as the bin size. Let's change it to 5 years. Now, let's give a gap width of 20%. Right-click on the histogram. Select Format Data Series. Select the gap width as 20%. Now, we have a histogram which shows age variation in a sample population and number of people that falls between 9 years to 89 years in 16 different bins. Simple, isn't it? Well, here ends the... Welcome back. In this tutorial, we will learn about Pareto chart. A Pareto or sorted histogram contains both columns sorted in descending order and a line representing the cumulative total percentage. Pareto charts highlight the biggest factors in a data set and are considered one of the 7 basic tools of quality control, as it's easy to see the most common problems or issues. Pareto chart is a slight variation of histogram where bins are reorganized from highest frequency to low and a line is overlaid showing total cumulative frequencies. Histogram and Pareto charts are commonly used to show the distribution of continuous data set. Perfect for showing distribution of heights or weights, population or age groups, exams and pass percentage, etc. In this chart, you can adjust the bin size to customize how you want to group values or range of values. Pareto charts are a great way to show the cumulative impact of each bin ordered by frequency or significance of continuous data set. So let's get started. Select the data. In this case, column with header height in inches. Click on Insert tab. Click on All Chart. Under Histogram, select Pareto chart and press OK. In this case, Excel automatically determines the bin sizes. We can also adjust the bin size based on our preference. To customize the bin size, click on the bin. Right-click, click on Format Axis. In this case, Excel has selected the automatic bin option. Let's change the bin width as 10 to make it more readable and simple. Right-click and add data labels. Let's change the title as Height in Inches. Now, bins has been reorganized from highest frequency to the lowest. And overlay the line chart showing cumulative frequencies. Now, let's give a gap width of 10% for the bins. Right-click, Format Data Series, select the gap width as 10%. Now, we have a Pareto chart which shows height variation in a sample population, which shows the number of people that falls between height of 48 to 98 inches under 5 different bins. Now, let's create a Pareto chart for the weight. You don't need to again create a new chart. Just copy paste the existing chart. Click on the chart, right click, select data series. Under legend entries, delete the current data series. Then click on add. Enter the data series as weight in pounds and select value as C2 to C120 and press OK. Add data labels. Let's change the title as weight in pounds. Let's customize the bin size and to make it more simple and easy to understand. Click on horizontal axis. Right click, Format Axis. Currently Excel has selected 14 as the bin size. Let's change it to 10 pounds. Let's give a gap width of 10%. Right click, Format Data Series. Select the gap width as 10%. Now we have a Pareto chart which shows weight variation in a sample population and number of people that fall between weight of 145 to 257 pounds in 8 different bins. Now, let's create a Pareto chart for age group. Like before, you don't need to create a new chart. Just copy-paste the existing chart. Click on the chart. Right-click, select data series. Under legend entries, delete the current data series. Then, click on Add. Enter the data series name as age group and series value as D2 to D120 and press OK. Add data labels. Let's change the title as age group. Let's customize the bin size to make it more simple and easy to understand. Click on horizontal axis. Right-click, Format Axis. Currently Excel has selected 13 as the bin size. Let's change it to 5 years. Let's give a gap width of 20% by right-clicking on the Pareto chart. Format data series, select the gap width as 20%. Now, we have a Pareto chart which shows age variation in a sample population and number of people that fall between age group of 9 years to 89 years under 16 different bins. Simple and useful, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about area chart. Area charts can be used to plot change over time, like years, months and days, or categories, and draw attention to the total value across a trend. By showing the sum of the plotted values, an area chart also shows the relationship of parts to a whole. You can use area chart to highlight the magnitude of change over time. There are different types of area charts like stacked area chart, 100% stacked area chart, 3D area chart, and stacked 3D area chart. The default area chart shows overlapping series. Area chart can be used to compare profit and sales over years, price changes over a period of month, and demand and supply over a period of time, etc. Keep the number of unique categories or data series low, like 7 or less. You can use a data validation and custom formatting to dynamically highlight specific slices of data or series of data in a stacked area chart to get a dynamic and interactive effect. Our data series contain headers like dates, shop A, shop B, etc. Select the data. Click on Insert tab. Click on All Charts. Select Area Chart. In the normal area chart, the data series gets overlapped and it's not helpful for understanding the data when you have large number of headers in your data. In this case, we are unable to distinguish between shop A, shop B, shop C and shop D sales. One way to overcome this shortcoming is by using the format features like increasing or decreasing the transparency, changing the color, etc. Still, the data gets messy and unclear. This is where stacked area chart comes in picture. To select the stacked area chart, right-click the chart, click on Change Chart Type and select Stacked Area Chart. This is very helpful as we can see each data series independently, and it also allows us to see how our data changes as days goes by. Let's change the chart title as Mobile Sales in Different Showroom. Now, let's see how a 100% stacked area chart looks like. Resize the current chart and then copy-paste the chart again. Right-click and change chart type as 100% stacked area chart. In this case, y-axis got rescaled to 0 to 100% range. You can also change the chart type to 3D area, 3D stacked area and 100% 3D stacked area chart. Simple, isn't it? Well, here ends this chapter. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about the line chart. Line charts are used to display trends over time. A line chart shows a series of data points connected by straight lines. It is a graphical object used to represent the data in your Excel spreadsheet. You can use a line chart when you want to show a trend over time in an order such as days, months or years. Line chart can show continuous data over time to an evenly scaled axis. Therefore, they are ideal for showing trends in data at equal intervals such as days, months, quarter or years. For example, profit and sales over years, price change over a period of month, demand and supply over a period of time, etc. In a line chart, category data is distributed evenly along the horizontal axis. Valued data is distributed evenly along the vertical axis. Line chart can be used to understand future trends. In a line chart, you can use polynomial or linear trend lines to forecast the future periods. You can combine line and column chart or other types of charts to trend two variables on a different scales. So let's see how it's done. In our example, we have headers like dates and shops. Let's see how our values changes over time. To create a line chart, select the data. Click on Insert tab. Click on All Charts. Click on Line Chart. Type of line charts include normal line chart, stacked line chart, 100% stacked line chart, line with markers, stacked line with markers and 100% stacked line with markers. You can also select 3D line chart. Select the normal line chart. Press OK. Now we have sales data from 4 different shops compared with dates and with each other. To make this a bit more readable, let's change the bound value in the y-axis. As we see, no sale has happened between 0 to 9 range and 55 to 60 range. Click on y-axis. Right click, Format Axis. Under bounds, change the minimum value as 5 and maximum value as 55. This is a great data source to use trend lines. Click on Design tab. Click on Add Chart Element. Click on Trend Line. You can choose from options like Linear, Exponential, Linear Forecast or Moving Average. Once you choose, Excel will ask you for which header you want the trend line to be added. In this case, I am selecting Shop A. Let's add one more trend line for Shop B so we can compare Shop A with Shop B. Once trend line is added, it becomes an independent element which can be formatted and stylized. You just need to right click on the trend line and Excel will show the format option available. Let's format the trend line a bit. Select the trend line. Click on Fill and Line. Select the color you prefer. Select the width you prefer. Under Effects, you can select the effect you prefer, like a shadow glow or a soft edge. Under Trendline option, you can select the style either as exponential, linear, logarithmic, polynomial, power, or moving average. You can customize your trendline names based on your preference. You can also do a forecast, either forward or backward period. Let's select the forward 10 periods. In this case, 1 period equals 1 day. As per this, forecast sales are going to decline for next 10 days. You can also show equation on the trend line and R-square value on the chart, where the R-square value indicates the fit of the trend line to the data set. It's a number between 0 and 1 where higher the number, better the fit. In this case, shop B has the R-square value of 0.0752 and shop A has the R-square value of 0.0033. To change the chart type, click on the chart, click on line chart and select stacked line chart or 100% stacked line chart or line with markers or other options available over here. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about charts like pie chart, donut charts and racetrack chart. Pie charts are a popular way to show how much individual amounts such as quarterly sales figures contribute to a total amount such as annual sales. Pie chart shows the size of the item in one data series proportional to the sum of the items. The data points in a pie chart are shown as a percentage of the whole pie. Pie charts can convert one column or row of spreadsheet data into a pie chart. Each slice of pie or data point shows the size or percentage of that slice relative to the whole pie. Pie chart works best when you have only one data series. None of the data values are 0 or less than 0. And you have no more than 6 categories because more than 6 slices can make a chart hard to read. In our data, we have headers like years and sales. Let's create a pie chart. Select the data. Click on Insert Chart. Select Pie Chart. Now that our chart is ready, let's add data labels. Let's format our data labels. You can add data labels based on series name, category name, value, percentage or legend key. Let's select value and value from sales, which is total revenue. You can position your labels either as center, inside end or outside end. To format your data series, right-click and select Format Data Series. Using Pie Explosion, you can explode your pie chart. You can add effects like shadow, glow or soft edges. In addition to normal pie chart, you can create a pie of pie or bar of pie or a 3D pie chart, etc. This chart shows smaller values pulled out into a secondary pie or stacked bar chart, which makes them easy to understand or distinguish. Now, let's create a donut chart. Donut charts have capabilities well beyond what pie charts can do. Doughnut charts display data in rings. You can add multiple rings where each ring represents a data series. If percentages are displayed in data labels, each ring will total 100%. Doughnut charts are best used when you have one or more data series that you want to plot. None of the values that you want to plot is negative. None of the values that you want to plot is 0. You don't have more than 7 categories per data series. The categories represent part of world in each ring of the donut chart. To create a donut chart, select the data. Click on Insert tab. Click on All Chart. And under Pie Chart, select Doughnut Chart. Add data labels. Click on Format Data Labels and click on Category Name. Now, let's add a new data series in the Doughnut chart. So right-click, select Data, add a new series, enter series name. select the series data and press OK. Now we have a new series. Let's add data labels. Format data labels and select label option as values. Press OK. Now let's format the chart to make it look better. Right-click, Format Data Series. Under Series option, select Doughnut hole size at 25% and Doughnut explosion at 25%. Add some effect. Simple, isn't it? Now, let's learn more about racetrack chart. Now, let's create another version of Doughnut chart called racetrack chart. Select the data. Now, we are going to select the data from headers like year, profit, target profit, and gap. Click on Insert tab. Click on All Chart. Select Doughnut chart. Delete the legend. Click on Format Data Series. Reduce the Doughnut hole size to 15% and select the angle of first slice to 8%. Each rings represent a different metric and segment of the ring is a category. Now, let's make each ring represent a category and each segment represent one of the metric. So, let's make each segment represent headers like profit, profit gap, and profit target. Let's do that by clicking the option Switch Row to Column. Now, the column became rows and the rows became column. Next, let's eliminate the gray fields. Click on the gray field and click on No Fields under the Format section. Now, you might be wondering how to identify which ring represent what. Well, it's simple. Just right-click and add data labels. We see 8,000, which is the profit in 5th year, and 500, which is the gap between the target and actual. Now, let's color each ring different to make it look better. Now, let's add some custom labels using Excel shapes. Since this is a modified version of the Doughnut chart, normal Excel labels will not function correctly. Now, let's add some more features to this chart. Add 5 boxes with colors that matches our rings using Excel shapes. To save time, I am using the boxes I had created earlier. The boxes should match the ring color. Again, to know which ring belongs to which data series, just right-click and add data labels. In this case, profit of 8,000, which is in red color, belongs to 5th year. Now, delete the data label. Click on the red box and enter the formula as equals header percentage of gap and cell value as F8. Replicate the same remaining 4 boxes. Let's format the boxes to make it look better. Select all box and make text color as white and alignment as center and increase the size. Now, what this does is, in case there is a change in the value in the data series like this, the same will get reflected in these shapes. Interesting, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about scatter chart. A scatter chart is a type of plot or mathematical diagram using Cartesian coordinates to display values for typically two variables for a set of data. If the points are color-coded, one additional variable can be displayed. Scatter charts are similar to line graph. They use horizontal and vertical axes to plot data points. However, they have a very specific purpose. Scatter plots show how much one variable is affected by another. The relationship between two variables is called their correlation. Scatter charts are used to plot data points on a horizontal and vertical axis in the attempt to show how much one variable is affected by another. Each row in the data table is represented by a marker whose position depends on its values in the column set on X and Y axis. The main difference between scatter and line chart is the way they plot the data on the horizontal axis. For example, when you use the following worksheet data to create a scatter chart and a line chart, you can see that data is distributed differently. In this example, we have headers like temperature in degrees Celsius, smoothie sales and predicted smoothie sales. Let's create a scatter chart. Select the data. Click on Insert tab. Select Scatter Chart. Here we have options like Scatter Chart, Scatter with lines and markers, Scatter with straight lines and markers, and Scatter with straight lines. Let's select the normal scatter chart and press OK. Now let's add horizontal axis and vertical axis. Now let's add a trend line, in this case a moving average. Let's add some styles to the chart. Now we have a correlation between smoothie sales and predicted smoothie sales when the temperature changes, which is a relation between two series of data. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about bubble chart. A bubble chart is like a scatter chart with an additional third column to specify the size of the bubbles it shows to represent the data points in the data series. Just like a scatter chart, a bubble chart does not use a category axis. Both horizontal and vertical axes are value axes. In addition to the X value and Y values that are plotted in a scatter chart, a bubble chart plots X values and Y values and Z values. You can use a bubble chart instead of a scatter chart if your data has 3 data series that each contain a set of values. The size of the bubbles are determined by the values in the third data series. Bubble charts are often used to present financial data. Different bubble sizes are useful to visually emphasize specific values. To create a bubble chart, arrange your data in rows or columns on a worksheet so that X values are listed in the first row or column and corresponding Y values and bubble size Z values are listed in adjacent rows or columns. Consider using a bubble chart when your data includes the following: 3 values per data point. 3 values are required for each bubble. These values can be in rows or columns on the worksheet, but they must be in the following order: X value, Y value, and Z value. Multiple data series. Plotting multiple data series in a bubble chart is similar to plotting multiple data series in a scatter chart. Scatter charts use sets of X values and Y values, but bubble chart use sets of X values, Y values, and Z values. When you create a bubble chart, you can choose to display bubble in 2D format or with a 3D effect. In this example, we have headers like temperature, smoothie sales, and predicted smoothie sales. Select the data. Click on Insert tab. Click on Scatter chart and then select Bubble chart. Now that our chart is ready, let's add vertical and horizontal axes, with vertical being smoothie sales. Now, let's format the axis. Right-click, select Format Axis. Under Format Axis, under Bounds, select Minimum as 150. Now, let's add some data labels. Right-click, Add Data Labels. Now right-click, select Format Data Labels and select the label position as Sender and label content as Y value. Now, let's add some format and styles to the chart. Now we are able to see the trends from a different dimension. Simple and useful, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about tree maps chart. A tree map chart provides a hierarchical view of your data and makes it easy to spot patterns like which items are a store's best seller, what is in demand, what is not in demand, etc. The tree branches are represented by rectangles and each sub-branch is shown as a smaller rectangle. The tree map chart displays categories by color and proximity and can easily show lots of data which would be difficult with other chart types. Tree map charts are good for comparing proportion within the hierarchy. However, Tree map charts are great at showing hierarchical levels between the largest categories and each data point. Disadvantages of tree map charts are: data must be sorted by category, missing many of the options available in other chart types. In our example, we have headers like brands, vehicle type, vehicle name, and sales number. Let's create a tree map chart. Select the data. Click on Insert. Under All Chart, select Tree Map Chart and press OK. OK. What this tree map is showing me in high level in colored box is which cars of which brand is selling the highest. In this case, the red color has the biggest box, and which means Mercedes-Benz is selling the highest number of cars under different models compared to BMW, Audi or Volkswagen. Next in line is Volkswagen and BMW, and finally Audi. One thing you should remember while creating tree map chart is the order in which categories should be grouped. Suppose in this case, if we copy paste Audi in between Mercedes-Benz, Excel will get confused and create a new box instead of categorizing the data with other Audi data. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about box and whisker chart. A box and whisker chart shows distribution of data into quartiles, highlighting the mean and outliers. The box may have lines extending vertically called the whiskers. These lines indicate variability outside the upper and lower quartiles, and any point outside those lines or whisker is considered as an outlier. Box and whisker charts are most commonly used in statistical analysis. For example, you could use a box and whisker chart to compare online marketing results or test results scores, etc. In our example, we have headers like months, regions like East, West, North and South. The next step is to enter the formula that will be used in the chart. We need to calculate the minimum, quartile 1, median, quartile 3 and max values. Later, the difference between those amounts are calculated to get the height for the box. The formula are listed below on the screen. From row A17 to A21, now let's make headers like minimum, quartile 1, median, quartile 3 and max. From column A16 to E16, let's make headers like criteria, East, West, North and South. Now, let's enter the formula in row B17 to B21 and then replicate the formula in other rows. First, let's enter the minimum, quartile, medium, quartile and max formula. Now, let's replicate the same by dragging and dropping to other rows. Now, let's create a box and whisker chart. Select the data from row B70 to E1. Click on Insert tab. Click on All Chart from the options. Select Box and Whisker Chart and press OK. Now, we have our box and whisker chart ready. Let's add data labels and then format data labels. Select the label contains as value and put label position as above. Now, let's understand this chart. Each box represents a category. Whiskers are vertical lines on the top and bottom of the box and shows your maximum and minimum values. So distance between top of the top whisker and bottom of the bottom whisker represent the spread from max to minimum. And within the box, here there are two attributes, which is the horizontal line which represent the median and a little x which represent the mean. Bottom of the bottom whisker to bottom of the box represent the first quartile for this data range. Distance from bottom of the box to horizontal line or median represent the second quartile. Top piece of the box is the third quartile, and finally from top of the box to the top of the top whisker is your fourth quartile. Box and whisker charts are a really good tool to describe statistical attribute with your dataset. Simple and useful, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about Sunburst Chart. The Sunburst Chart is ideal for displaying hierarchical data. Each level of the hierarchy is represented by one ring or circle with the innermost circle as the top of the hierarchy. A Sunburst chart without any hierarchical data looks similar to a Doughnut chart. However, a Sunburst chart with a multiple levels of categories shows how the outer rings relate to the inner rings. The Sunburst chart is most effective at showing how one ring is broken into contributing pieces. Advantages of this chart includes quick visualization of hierarchical data, at a glance breakdown of data in categories. Disadvantages include data must be sorted by category, limited option for controlling format and presentation. In our example, we have headers like office location, department, manager, team lead, employee, and count. Now select the data. Click on Insert tab. Click on All Charts and select Sunburst chart. Now we have our Sunburst chart ready. We have data based on office location, department manager, team leads, and employees in this chart. As we add or delete the data, Sunburst chart changes the appearance dynamically. Let's add some legends to make the data more simple to understand. Useful, isn't it? Well, use Sunburst chart if you have fewer categories of data. Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about Waterfall Chart. A waterfall chart shows a running total as values are added or subtracted. It's useful for understanding how an initial value, for example, net income, is affected by a series of positive or negative values. The columns are color-coded so you can quickly tell positive from negative numbers. The initials and final value columns often start on horizontal axis, while the intermediate values are floating columns. Because of this looks, waterfall charts are also called as bridge charts. Best used for comparing income and expense, evaluating company profit, comparing product earnings, highlighting budget changes on a project, analyzing inventory or sales over a period of time, showing product values over a period of time, visualizing profit and loss statements, creating executive dashboards, etc. In our example, we have headers like ledger entries and total. We have an example of quarterly result where there is a net loss of minus 295.39. Let's see how waterfall charts help us understand the result statement. Select the data. Click on Insert Chart. Click on All Chart and select Waterfall Chart. Now we have our chart ready. Change the title to Quarterly Result. Now let's understand this chart. In the first box we have net sales as 63.01. In the second box we have total expenditure as 120.81. Wherever there is an increase in value, the box has gone up, and wherever there is a decrease in value, the box has gone down. The last box shows us there is a net loss of 295.39. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about funnel chart. A funnel chart shows values across multiple stages in a process. For example, you could use a funnel chart to show the number of sales prospects at each stage in a sales pipeline. Typically, the values decreases gradually, allowing the bars to resemble a funnel. A funnel chart is similar to a bar chart, but the bars are centered to create a funnel shape. Funnel chart can be used to understand how effective the sales team is working in closing the sales. To understand web analytics based on visitors data, number of hits, duration of visits, and successful sign-ups, you can use a funnel chart. To understand how many orders are initiated and how many orders are closed and how many are cancelled, you can use a funnel chart. You can find sales in each region by each salesperson. Funnel chart can also be used to evaluate recruitment process. In our example, we have headers like details and numbers. Under details, we have info like total candidates interviewed till date and total candidates who have joined. Now, let's create a funnel chart. Select the data. Click on Insert tab. Select All Chart and select Funnel Chart and press OK. Well, now data is represented in a funnel chart from increasing to decreasing order. Now, let's create one more type of funnel chart called aesthetic funnel chart that actually looks like a funnel. Select the data and insert a 3D stacked column chart. To design the chart, right-click on the columns. Select Format Data Series. Click on Series option in the Format Data Series panel. Select Full Con under Column Shape. Fine-tune the chart as follows. Click the Design tab on the ribbon. Click Switch Row to Column. Right-click on the vertical axis and select Format Axis from the drop-down list. Click Axis options in the Format Axis pane. Check the box Values in reverse order. Deselect all the chart elements. Right-click on the bars and select Format Data Series from the drop-down list. Step 7. Click on Series options in the Format Data Series pane and type 50% for gap depth under Series option. Format your chart with the details as follows. Select the data labels in chart elements. Place them and format them. You can choose callout option for the data label of the bottom part. Give a chart title. Your funnel chart is ready. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about radar chart. Radar chart is used to understand the magnitude of many variables for several different independent variables in one chart. A radar chart in Excel is set up like a wheel with spokes for each variable. Concentric lines connect each spoke and make up a particular measure of units. Each point is plotted for each variable on the spokes and they are connected with lines. The radar chart, also sometimes called a spider or a star chart, lets you compare multiple items against multiple criteria. You could use it to see how temperature changes in multiple locations over the course of a year, or quickly compare products in different areas. Radar chart can be used for comparing multiple vendors, comparing sales of 2 or more products, etc. Radar chart normalize each metric to the same scale like 0 and 1, 1 and 10, and 1 and 100 to improve readability and create meaningful comparison across data series. In our example, we have details of how we rate 2 vendors based on multiple criteria. To create the chart, select the data, click on Insert tab, and under All Charts select Radar Chart. In our example, vendor A is compared with vendor B based on the feedback received from customers. Now the radar chart is ready. Your chart grows and changes shape based on the new data that is inserted. Let me insert some rows to show how it works. The radar chart is one of those love it or hate it tools. This is probably because there is some data that it works really well for, and for some it merely creates confusion and annoyance. The trick is to use it sparingly and only on those specific tasks to which it is most suited. Simple, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, we will learn about stock chart. Stock chart, as the name indicates, are useful to show fluctuation in stock prices. However, these charts can also be used to show fluctuation in other data also, like daily wind speed, rainfall, or temperature. If you use a stock chart to display the fluctuation of stock price, you can also incorporate the trading volume. For stock charts, the data need to be in a specific order. For example, to create a simple high-low close stock chart, Arrange your data with high, low and close, entered as column headings in that order. A stock chart has the following subtypes: high, low, close, open, high, low, close, volume, high, low, close, and volume, open, high, low and close. Now let's try the first chart, high, low and close. The high, low and close stock chart is often used to illustrate the stock prices. It requires 3 series of values in the following order: high, low and then close. In our example, we have headers like date, open price, high price, low price and close price. Let's create a stock chart. Select the data. Click on Insert tab. Click on All Chart and select Stock Chart. Now we have our numerical data represented in a graphical form. Let's add some axes to make the data more simple. Now let's create a chart with volume, open, high, low and close. You can get the historical stock price from websites like Yahoo Finance and automatically update data on a periodic basis using the web link. Simple and interesting, isn't it? Welcome back. In this tutorial, we will learn about 3D maps. Microsoft 3D Maps for Excel is a 3-dimensional data visualization tool that helps you look at information in new ways. 3D Maps lets you discover insights you might not see in a traditional 2-dimensional table and charts. With 3D Maps, you can plot geographic and temporal data on a 3D globe or custom map, show it over time and create visual tools you can share with other people. You can use a 3D map to map data. Plot more than 1 million rows of data visually on Bing Maps in 3D format from an Excel table or a data model in Excel. Discover insights. Gain new understanding by viewing your data in geographic space and seeing timestamped data changes over time. Share stories. Capture screenshots and build cinematic guided video tours you can share broadly, engaging audience like never before, or export tours to video and share them that way as well. You will find the 3D map button in the Tools group on the Insert tab of the Excel ribbon as shown in this picture. When you have an Excel data that has geographic properties in table format or in a data model, for example, rows and columns that have names of cities, states, countries, zip codes, country region or longitude and latitude, etc. For best result with 3D maps, use data in an Excel table or preferably a data model you created in Excel or by using Power Pivot. If the data you want to use in 3D map is stored on external servers, you can connect it to from Excel and add it to the data model. To prepare your data, make sure all of the data is in Excel table format where each row represents a unique record. Your column headings or row headings should contain text instead of actual data so that 3D maps will interpret it correctly when it plots the geographic coordinates. Using meaningful labels also makes value and category fields available to you when you design your tour in the 3D Maps Tour Edition pane. When you work with large amount of data, you might see quality issues such as typos and inaccurate data. You may want to check the data before you plot it with 3D map geographic time and measure and then check what 3D map has plotted. So let's get started. Now we have the data related to power station with headers like state, country, company, plan name and others. We have around 17,600 rows of data in this Excel sheet. To create the 3D map, select the data, click on 3D map, click on new tour. Excel will take a few moments to launch the power map. Now we have a 360-degree map in which we need to plot our points. In Power Map, we have fields like Tour, Scene, Layer, Map, Insert Time and View, which will help us customize our 3D map. Now we have our field list. First, let's drag and drop country and state under location to plot our data. Capacity megawatts under heights. Company under category. Initial date of operation under timeline. Remove all legends. And now we have an actual functional 3D map. You can change the map type to flat map by clicking on flat map. Click again and it will change back to 360-degree map. You can add or remove labels. You can change the shape of the icons. You can change the theme. If you zoom in, you will see that this is the actual geographic lane. You can click on any points to get more details. For customization, we have our layer option where we can increase or decrease the height. You can also increase or decrease the thickness, opacity, and color options. Once done, you can play the tour to see how data changes over time. Interesting, isn't it? Well, here ends this tutorial. Welcome back. In this tutorial, we will learn about combo chart. Combo chart help you combine two or more chart types to make the data easy to understand. It is represented with a secondary axis. This chart is even easier to read. You can use a combo chart when the number in your data vary widely from data series to data series, or you have a mixed type of data, for example, price and volume. You can plot one or more data series on a secondary vertical axis. The scale of the secondary vertical axis shows the values for the associated data series. Follow the steps to insert a combo chart in your worksheet. In our example, we have headers like month, desktop ads, mobile ads, total cost, click, etc. We got a combination of volume details and rate details, and both falls under different scales. And to plot them on the same chart or graph, we need to combine different types of charts and secondary axes to help the viewers understand the insight of the data in a simplified manner. Now, let's create our chart. Insert a basic 2D column chart. To select the data, right-click on the chart. Select Data. Add a series for unique clicks. Select the values. Press OK. And select Horizontal Axis label as months. Now, add a second series for cost per click. Select the data. Press OK and select Horizontal Axis label as months. Now, let's change the chart type. Right-click, change chart type, select Combo Chart. Select primary chart as clustered column and secondary chart as stacked line with markers. Select the secondary action. And now, we have a combo chart. Let's add some axes. Primary vertical as cost per click. Secondary vertical as unique click. And title as ads revenue. Let's add some styles to the chart. Simple, isn't it? Now, let's create one more chart for comparing leads and ads total cost. Copy-paste the existing chart. Now, click on the chart and Excel will show the data pertaining to the chart series. Drag and drop the series and series values to create a new chart. In this case, from unique clicks, change to ads total cost, and from cost per click, change to leads. Now change axis primary vertical as leads, secondary vertical as unique click, and title as ads total cost. Let's add some styles to the chart. Useful, isn't it? Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, you will learn more about how to add shapes in dynamic column chart. You will learn how to add dynamic conditional formatting effect, how to add shapes in a chart, and how to customize them to present data in an impressive way. In our data, we have headers like quarter and sales. First, let's create a column chart with this data. Select the data. Click on Insert tab. Click on All Chart and select Column Chart. Let's remove grid lines, axis lines from this chart and add data labels. Now, right-click and click on Format Data Series to decrease the gap between bars. Let's keep the gap width as 70%. Let's change the title as Quarterly Sales Data. Now, format the shape outline as no color. Using the if, max and min formula, let's conditionally format bars with highest and lowest value. For this, we need to use a new data series. In row C2, insert the formula equal to if open bracket B2 equals max open bracket, select the data range B2 to B5, insert constant, close bracket, comma, B2, comma, open double quote, close double quote and close bracket. Replicate it in other rows. Now in the data series, the row with the maximum value will get reflected under max header adjacent to the data series and all other cells will be blank. Now let's do the same for minimum value. Now for minimum formula, let's insert a new data series. In row D2, insert the formula equal to if open bracket B2 equals minimum open bracket, select the data range B2 to B5, insert constant, close bracket, comma, B2, comma, open double quote, close double quote and close bracket. Replicate it in the other rows. Now in the data series, the row with the minimum value will get reflected under minimum header adjacent to the data series and all other cells will be blank. Now let's add max and min data to the data series. Click on the chart. Right click, select data, click on Add button. Select series name as row C1. Select series data and click on OK. Now for minimum value, click on the chart. Select data. Click on Add button. Click series name as row D1 and select series data. Click on OK. Now for the bar that reflects highest value, let's change the color as green, and for the bar that reflects lowest value, let's change the color as red. Now you can see the space between the two column chart which we need to correct. So right click, format data series. Under series overlap, change it from -27% to 100% and press OK. Now the max and min value is reflecting on top of the existing chart. Now the chart is fully dynamic. If you change the value, the data will reflect accurately. Now let's learn how to add shapes in our chart. Make a copy of your existing chart. Select a shape which is more rounded at the edges from the Insert Shape option. Make 3 copies, one for the regular bars, one for the max bar, and one for the minimum bar. Change the color and size to match the chart. To insert the shapes to the bars, copy the shape, click on the chart and paste it on the chart. To add the shape to the max and min series, select the shape color and paste it on the respective bars. Now, if you noticed the data series that are bigger, the shape appears to be stretched out. To avoid this, we need to split each data series into 2 data sets. The top data set will remain constant to all bars and bottom data set will be stretched out, which is a rectangle. To do this, we need to use a stacked column chart. Let's add 2 more data series, Series 1 and Series 2. For Series 2, let's consider the value as minimum of data series B2 to B5. So let's add the formula as equal to minimum, open bracket, select the data B2 to B5, insert constant and close bracket. Now divide it by 2. This will be the size of the top stack. As we inserted constant, the data in all the rows will be the same. Now for my bottom stack, let's deduct the original value from the top stack, which is row B2 minus F2. Let's create a stack column chart with this data. Select the data in column A, E and F and click on Insert Chart, All Chart, and under Column Chart, select Stack Column Chart. Let's change the header as Quarterly Sales Data. Let's delete the axis, grid lines and series. Now, let's change the gap width of the bar as 50%. Now, let's add the shapes to the chart. Add data labels to the top and bottom stack chart. Let's change the font color to white, make it bold and make the size a bit bigger. Value that data label showing is of Series 2. We need the data label to show the value as sales from row B2 to B5 by selecting Value from Cell. Now, let's add the data label to our second stack chart. Right-click, Add Data Labels. Format the data labels, unclick Values and select Category Name. Let's change the font color to white, make it bold and make the size a bit bigger. Now, let's add shapes to the top part. Reposition the axis label for bottom part to bottom base. Now, Let's add the conditional formatting to this chart using stacked column chart. Let's add 4 more series which are max and min for series 1 and max and min for series 2. So the formula is same as before. For series 1 max, the formula is equal to if open bracket B2 equals max open bracket, select the data series B2 to B5, insert constant, close bracket, comma, select row E2, comma, 0 and close bracket. For series 1 min, the formula is equal to if open bracket B2 equal to min open bracket, select the data series B2 to B5, insert constant, close bracket, comma, select the row E2, comma, 0 and close bracket. For series 2 max, the formula is equal to if open bracket B2 equals max open bracket, select the data series B2 to B5, insert constant, close bracket, comma, select row F2, comma, 0 and close bracket. For series 2 min, the formula is equal to if open bracket B2 equals minimum open bracket, select the data series B2 to B5, insert constant, close bracket, comma, select row F2, comma, 0 and close bracket. Now let's make the series reflect in a chart. For series 1 max, right click on chart, select data, add series, select the series name, select the series value and press OK. For series 1 min, right click on chart, select the data, select the series name, select the series value and press OK. For series 2 max, right click on chart, select the data, add series name, select the series value and press OK. For series 2 min, right click on chart, select the data, select the series name, select the series value and press OK. Now we have 2 stack charts on top. To correct this, what we need to do is, we need to change the chart type to combo chart, where we can use the primary and secondary axis. Before that, make sure all the charts that are reflecting are stacked column chart. Now, for series 1 max and min and series 2 max and min, select the secondary axis. Now, for the highest bar, let's set the color as green, and for the lowest bar, let's set the color as red. Well, now our chart is ready. Simple, isn't it? Now let's test it. Well, it works perfectly. Well, here ends this tutorial. Learn more from the next tutorial. Welcome back. In this tutorial, you will learn how to create dynamic map chart which will show you any details you want by geography, be it sales, be it revenue, employees, profit or growth rate. Our data has headers like categories, regions and sales, etc. We are going to use two types of charts in this example like XY scatter plot and bubble chart. Scatter plot helps us to plot values on x-axis and y-axis, which will help us plot the regions on the map. As a first step, let's create X and Y scatter chart. The chart is showing blank since we haven't added or selected X and Y values. Now, we need a world map to plot the regions. For that, either you can use a map on your system or you can download it from online. Right-click on the chart. Click on Format Chart area. Click on Online if you are searching for an online image. In the search bar, type Vector Map, World Map and press OK. When you select the image, please do check for the usage policy. Let's select this one and let's see its image usage policy. In this case, the image is free for commercial use and no attribution is required. Select the resolution and download it to your system. Now that we have our map ready, let's first lock the aspect ratio of the image and under Property, click on Option Don't Move or Size with the cells so that our map doesn't move as a new data, row or column are inserted. Now, we need to plot the points in this map. We need to fix the axis between value sets like 0 to 10 in the x-axis and y-axis or 0 to 100 in the x-axis and y-axis, etc. In our example, we are going to use 0 to 10 points. In this table, we have headers like X, Y and region. The data from this table is going to reflect in the map. We are going to plot regions on this map based on X and Y values on an assumption. You can always change this plot later. Or you can also select primary horizontal axis and primary vertical axis to understand the plot. First, we are going to plot Africa on the X and Y axis in this map. Let's put X-axis as 4 and Y-axis as 4.5 on an assumption basis. For North America, let's put X-axis as 1.5 and Y-axis as 6. For Australia, let's put X-axis as 7 and Y-axis as 2.5. For Europe, let's put X-axis as 4.2 and Y-axis as 7. And finally, for Asia, let's put X-axis as 6.5 and Y-axis as 5.8. Now, let's plot this data on the chart. Right-click on the chart, select Data, Add Data Series. Select series name as Regions and select Series X value and Series Y value. Press OK. Now we can see our series location on the chart as a black circle representing each regions. Let's add a drop-down list for the categories. Click on the row where you want the drop-down to reflect. In this case, row J21. Then click on the Data tab. Click on Data Validation. Click on List from the drop-down and select the categories. Press OK. Now we have our drop-down list ready. Now we need to set a reference way when a user selects electronics from the drop-down. The total sales should reflect pertaining to that region on the map. For this, we need to use the SUMIF formula. So let's do it. In row I-24, insert the formula equal to SUMIF, open bracket, select the data range C2 to C21, which is a total sales. Insert constant by pressing shortcut key Fn plus F4 if you're using a laptop and just F4 if you're using a desktop, so that the range doesn't get changed when we drag and drop the formula. Comma, select the data range B2 to B21, which is the regions. Insert constant by pressing the shortcut key Fn plus F4, comma, select H24, which is our criteria 1, which is the region, comma, select the data range A2 to A21, which is the categories. Insert constant, comma, select the data from J21, which is our drop-down criteria. Insert constant and close bracket. Now, if we select the drop-down, the values will reflect accurately in the field. Next, let's replicate this data on the map. First, let's change the chart type from scatter plots to bubble chart. Next, right-click, select data. Change the series name as total sales. Select the x-axis and y-axis and select bubble size data series as total sales row I-24 to row I-28. Press OK. Now let's resize the bubble chart by area or width. You can also scale bubble chart based on the size. Right click on the bubble chart. Select the width and scale size as 80. Now let's add data labels. The data labels which is currently reflecting in y-axis value. Let's change that. Right click on data labels. Select bubble size and unclick on y value. Now we have our total sales. Let's label the position as sender. Next, if you want to find out which region has the highest and lowest sales in categories like electronics, clothing, etc., without looking at the numbers or size of the bubble, we need to add a new series and use a combination of if, max and min formula. So in this case, first for max formula, in row J24, insert the formula equal to if open bracket I-24 equals max open bracket, select the data series from I-24 to I-28, add constant, close bracket, comma, I-24, comma, open double quote, close double quote, and close bracket. This means if the data in the row is maximum compared to the data series, the cell value will be displayed, else the cell will return a blank value. Next, for minimum formula, in row K24, insert the formula equal to if open bracket I-24 equals minimum open bracket, select the data series from I-24 to I-28, add constant, close bracket, comma, I-24, comma, open double quote, close double quote, and close bracket. This means if the data in the row is minimum compared to the data series, the cell value will be displayed, else the cell will return a blank value. Now let's see if it's working. Well, it does. Now let's add this to the chart. First, for max sales, right click, select data, add series, select series name as max sales. Select x-axis and y-axis and bubble size as max sales data series and press OK. Next, for minimum sales, right click, select data, add series. Select series name as minimum sales. Select x-axis and y-axis and bubble size as minimum sales data series and press OK. Well, now based on the selection of the drop-down, you can find the regions where max and min sales happened dynamically. Simple, isn't it? Well, here ends this tutorial. Learn more from the next